Hey everyone. So we're going to be looking at some chemistry. So this is just a continuation of the notes that we started yesterday. So just to review the few notes that we did get down, atoms are the smallest unit of matter. Everything's made up of atoms. The smallest amount of matter you can have is one atom. And atoms are made up of three what we call subatomic particles. So they are the protons, which are positive, neutrons, which are neutral, they have no charge, hence the zero, and electrons, which are negative. And they are located here. So this is just one model that we use to represent atoms. We call it the Bohr model. So in the center, we have the nucleus, and in the nucleus, we have protons and neutrons. And you can see that I have color coordinated it to match this model. So the neutrons are green, the protons are red, and the electrons are blue. And the blue electrons circle the nucleus, and they don't really interfere with the nucleus at all. So, really, anything smaller than an atom is not really matter, it would just be subatomic particles. Now, when we get into elements, the smallest amount of an element is one atom of an element. So if you're talking about, having some carbon or if you're having some gold or silver, the smallest part of each of those elements that we can have is just one atom of those elements. So how do we know which element we are working with besides me just telling you what we're working with? This is when, okay, we can look at our periodic table and um, we're able to count the number of protons, which I'll show you on the periodic table how this relates. And okay, and all elements are defined by the number of protons. So you could have, um, 5 protons and 1 electron, but that atom would still be what we consider boron or hydrogen, which is element number 1. You could have 1 proton, 5 neutrons, no electrons, and it would still be considered hydrogen. So protons, or the number of positives in the center in the nucleus, is the way we define what kind of atom, or sorry, what kind of element you are working with. So what we're going to do is take a look at the periodic table, and we're going to kind of examine how to read it. And for those of you who have already done this, or you've seen the periodic table before, hopefully this is just a review. So the periodic table is broken down into many different sections. And as you can see, this one is color coordinated. Yours is obviously not, since it's black and white on my printer, but we have different groups, which are denoted by the numbers here. 1 and 2 are super reactive, and so is number 17. This middle part right here, like this like kind of salmon peach color, is what we call the um, transition metals, and they're generally unreactive, and they don't really act too much. So and then over here in group 18, we have the noble gases, and the noble gases are really unreactive, hence why they're called noble gases. So, how do we look at all of these bizarre numbers that are on your periodic table? The first thing to note, which I have up here, is the atomic number. So, the atomic number is the number at the top of each box, and that is 1, 2, 3, 4, 5, 6. And if you notice, all the elements just go in numerical order. And the way that they're organized is by the number of protons. So hydrogen has 1 proton, so therefore it's element number 1. And that's what its atomic number correlates to. So atomic number is the number of protons. The other really, really important information is on the right hand side, which is the number of electrons. So you'll see in a second, electrons are put into specific places. They're not just kind of swirling around. They are in what we call shells or energy levels. And so if you look on the right hand side of all of the elements, you've got these numbers listed on top of each other. So boron has number 2 listed and then it has a number 3. So basically, what it's saying is that in the first shell or energy level, there are only 2 electrons located. And in the second one, there are 3. Generally speaking, the number of electrons and the number of protons, which is the atomic number, are going to be the same. You want them to be the same because you want atoms that are neutral and unreactive. It's when they are not the same that you start having big chemical reactions. So, what I want us to look at is something called a Lewis dot structure. Okay. So the Lewis dot structure is based off of this principle of electron shells. So if you imagine this being like an atom and it was cut into a small like slice, the green represents the nucleus. Every electron shell can only hold a certain amount of electrons. We don't really have to worry about numbers going out this far. The most we would maybe get to is the fourth shell, but even then that's a lot of electrons to draw. So the first shell can hold 2. The next one out can hold a maximum of 8, and then 1832. Even though it can hold the maximum number, it doesn't mean it will hold it. That just means that that's the maximum it could possibly hold. It will probably hold less as the further out you go. So what we want to do is draw these diagrams called Lewis dot structures because what it does is it helps us understand how elements react to each other and how do we know which elements are the most reactive. And in the long run, what's going to help us understand is how carbon molecules, which are what we're made up of, how they react to each other and how they interact. So what we want to do is draw hydrogen. And the first thing we want to do is look at your periodic table of elements. Okay. So you find your element, whatever you're working with, in this case it's hydrogen, and you're going to look at, okay, you're going to look at your symbol, and then you're going to actually write the symbol in the box. So what I'm referring to now, I'm just going to zoom out for a second and go to this, right? What I'm looking at now is your Lewis dot worksheet, okay? And we're just going to focus on these 2 columns right now. Don't worry about the other ones. Okay. So step 1, look at the periodic table, find your element. Step 2 is to write the symbol of your element. Step 3, you're going to draw a box around the symbol. And the reason why we have a box is because the maximum electrons you could possibly have in the outer shell of an element is 8. So this represents a possibility of 2, 4, 6, and 8. And the box helps us kind of conceptualize that. In step 4, you're going to look at the number of electrons on the right-hand side of the periodic table box. So if I go up here, there is a number 1. So there's only 1 electron. And the last number is the number of dots or electrons that we draw. So since there's only a number 1, we're only going to draw 1 electron. So there's 1 electron total, and there's only 1 what we call valence electron. So the valence electrons are the things that we need to keep in mind because they're the ones that are going to tell us how reactive our elements are. And since there's only 1 electron for hydrogen, hydrogen kind of bonds with a lot of things. So in your Lewis dot structure worksheet, I think it already has hydrogen, but you can just kind of compare the 2, make sure that it looks good. Okay. Let's try helium. So helium, we're going to look at the periodic table and we're going to find the element. Step number 2, we're gonna write the symbol of the element. So you should be on your Lewis